New study shows asbestos fibers can move in soil. Another study demonstrates asbestos strands can travel through sand and soil, a leap forward that difficulties current remediation systems for counteracting introduction to the disease, bringing on mineral. Geologist Jane Willenbring of the Scripps Organization of Oceanography at the College of California, San Diego drives the continuous study. The primary stage tried the long-held conviction that asbestos waste heaps are secured when topped by soil. Willenbring's postdoctoral specialist Sanjay Mohanty of the College of Pennsylvania found that when natural acids coat asbestos filaments, the strings can go through sand and soil. This is something that can happen in soils, where you have natural acids that are made from plants, growths, furthermore microscopic organisms, Willenbring told Asbestos.com. These natural acids can coat the outside of the strands and really change the portability of the filaments. A lot of asbestos waste covered in nature have concerned researchers and earthy people for a considerable length of time, yet shockingly, few have investigated how asbestos filaments pollute groundwater. They discover it in water, and they know where the asbestos is, so they can expect transport, Willenbring clarified. However, this is the first occasion when anybody has put a known measure of asbestos in the highest point of a dirt section and really saw some asbestos turning out. Drawn-out presentation to asbestos may prompt mesothelioma, an uncommon and serious malignancy. Willenbring introduced her discoveries in August at the 2016 American Compound Society meeting in Philadelphia. The National Foundation of Ecological Well-Being Sciences supported the task. The EPA, superfunds and overseeing asbestos tainting. The Natural Insurance Organization, EPA, set up the Exhaustive Ecological Reaction, Remuneration and Obligation Demonstration of 1980, CERCLA, to survey and reserve the cleanup of risky waste locales, incorporating those contaminated with asbestos. Ranges vigorously debased by any perilous chemicals or different toxins are called Superfund destinations. The National Needs List, NPL, incorporates the most noteworthy needs superfunds. There are presently 1,338 government and general locales on the rundown, 13 of which are asbestos-related destinations. Willenbring and her group took soil tests from the Beaurit asbestos site in Ambler, Pennsylvania. Kane Center Incorporated, the property's proprietor, dumped asbestos-containing materials from a close-by assembling plant at the 6th section of land site from the mid-1900s to the late 1960s. EPA reports demonstrate the waste heap is almost 25 feet high. Government authorities added the site to the NPL in April 2009. Teams topped the whole site with soil in 2015. Topping is still viewed as the most secure remediation system for asbestos. Pulling materials away could demonstrate more hazardous, and controlled nearby cremation is dreadfully immoderate. Truly, the EPA did as well as could be expected, and it's such a great amount of superior to the way it was before, Willenbring said in regards to asbestos soil topping. This examination is to attempt and see how you can improve, which is something you generally make progress toward. Comprehension of asbestos portability is still restricted. In 1977, the EPA discharged a report expressing asbestos movement through soil won't be an issue of any hugeness. From that point forward, science and examination indicates colloids, or a blend in which one substance is separated into colloidal particles and scattered during a time substance, travel through soil, conveying other hurtful contaminants with them. In spite of this, the study calls attention to the comprehension of asbestos portability stays constrained. Colloids really don't generally settle in water, on the grounds that the little, modest developments of the water around them keep the colloids in suspension, Willenbring clarified. Asbestos strands can really act a considerable amount like colloids. Willenbring clarified minute asbestos strands and other unsafe substances, for example, radioactive waste, can join themselves to colloids. When we began this venture, we believed that definitely somebody would have taken a gander at whether asbestos can travel through soil, Willenbring said. Additionally, what are the controls? Not all dirts are made equivalent. So what are the geochemical triggers that may make asbestos filaments be discharged from the dirt? Willenbring focused on that while asbestos filaments traveled through the Bow-Rit soil tests in lab tests, it doesn't inexorably mean the strands at the Superfund site in Ambler are portable or that they at present exist in the territory's groundwater. There's no confirmation that it's relocating through the dirt in regular conditions, she said. Discoveries of the asbestos in soil study. Scientists have chipped away at the continuous lab segment of the study for 2 or 3 years. It began with a sand segment test to figure out if untreated asbestos filaments can travel through sand. Conclusion: they proved unable. Be that as it may, the group found asbestos strands traveled through the sand section when they were covered with fulvic corrosive, humic corrosive and other regular natural matter. Scientists later ran a comparative test utilizing the Bow-Rit soil tests. We found that in the event that we covered these strands in natural acids, we could really get the asbestos filaments to travel through the dirt, Willenbring said. She likewise called attention to the special perspective proportion of asbestos strands, more long than slender. As a result of their shape, analysts suspected asbestos filaments went head-to-head with each other in the dirt as opposed to moving openly through it. What's next for specialists? Willenbring and her group keep looking into new bearings for the study. One thought: make sense of how to direct the measure of natural acids in the heaps to breaking point or lessening the measure of development. We could accomplish another thing to the heaps to influence their geochemistry so we don't get transport, she said. Willenbring said one choice may include adjusting the fabric utilized between the asbestos materials and the dirt to influence the heap's geochemistry. Another key may lie in keeping plants alive on the dirt over these topped heaps. Soil scientist Brenda Casper is working with Willenbring and others to figure out which local grasses best hold the topsoil. In the event that you don't have plants on the surface of the heaps, then you have more disintegration of that top, and in the end, it will simply have the same issue once more, Willenbring clarified. While grasses and local plants could demonstrate advantageous, Willenbring said trees developing nearby the heaps are tricky in the event that they fall on the grounds that their broad root frameworks could uncover covered asbestos materials. In a spot like Pennsylvania, you regularly have trees come in regardless of the fact that you don't need them, she said. What you fundamentally need to do is cut the surface so the seedlings don't get an opportunity to grab hold. Willenbring additionally called attention to that not all dirts are made equivalent, so one remediation methodology at a site like Bow-Rit could have diverse results in spots like Libby, Montana, the site of the biggest, longest-running asbestos cleanup venture in U.S. history. We don't yet have soil from Libby, however it is extraordinary to make them, Willenbring said. Everybody is stressed over Libby, and we are as well. Willenbring utilized Libby for instance of how development of asbestos filaments won't not be a terrible thing, sometimes. On the off chance that the filaments move to groundwater, as a rule that would move them more profound and more profound into the ground, diminishing the danger of introduction. The issue then comes when individuals choose to do things like flood, which can make a pathway between the subsurface and the surface where when the water dries out, it can prompt asbestos inward breath dangers. That is the sort of thing that stresses us and why we're keen on discovering approaches to offer assistance.